Did the streaming also so that people can watch it later if they are okay. So what I was suggesting, so just go through line by line code. Okay, it will help you. So can you check the supplementary content?
Okay, okay.
Okay.
Actually, my doubt was that, like, how far, because of course there are lots of tutorial videos available in the internet. So, how far should I go for this course?
Okay, so first of all, what I will suggest, just try to go, line by line code, okay, which we are providing for every week. Okay, see,
Okay,
anyway,
okay,
Professor Siva, he had just uh, he didn't discuss the code in a deep way. He just simply mentioned the things, but code are simple. So what you can do, just try to go line by line, and
mm-hmm.
you can ask to us. We are there, and
Mm-hmm.
also there are lots of things available on general internet
Okay.
and all. You can try for that, but I'm sure if you know the Python and all, so it's that will not I mean it will not be very much difficult to understand the code. If you have any doubt, so I think you are in that group, right? The G space we have created.
Yes, yes, sure,
Okay,
sure,
so
sure.
yeah, so you can ask there anytime you had this code, so we can discuss. That's not a problem at all. Okay.
Okay, okay, okay,
That's-
okay.
so if you have any concept related doubt, or if you're not able to get the any code, so you can let me know. So like
Sure.
in Python and all, there are lots of for visualization there are another syntax. Okay, in R the difference is you can, okay, suppose okay, I will take an example. Suppose I want to plot a scatter plot between two variables, let's say x and y. X, just assume x is independent, y is response dependent variable. All right, so I can
Yeah.
simply write a command plot x comma y, and if I can add a label for what kind of line type I want. All right. Now in the same
Yeah.
thing, in R there is called ggplot. So ggplot stands for grammar of graphics. Okay. So grammar of
Okay.
graphics is, so it will give you the plots and all in a very you can say in a standard form, or in a very clear way, or you can say it's a it's a very good thing. See, plot will give you the same thing. Ggplot will give you you can simply say with more facility. Okay, so
Okay.
so anyway we have to just keep in mind some syntax, some library and all, but those no uh, it will be very familiar to you when you are you will code lots of. That's all. That's not a problem. Anyway, for every week we will provide the code. If still you have any doubt and also, you can ask at any time. All right. So as of now, if any one of you doubt regarding any concept of week 1 or week 2 or in any code, then uh, free to ask. Feel free to ask. We can discuss that. Abhishek, Manasita, Ananya, Pooja, do you any question? Or any?
Is actually
Mhm.
my next question would be like the T, the T
Districts.
distribution.
Yes.
Yes, the T
Mhm.
distribution.
Mhm.
Uh, could you please a little bit elaborate on that? Because I understood the how it is coming to the T distribution. I understand, but where it is used, and if you can little bit explain the formula of that, the exact formula.
Okay, formula means you want PDF or
Yes,
the
distribution function.
history behind the T distribution and all.
Yes, yes. The main distribution formula for that T distribution, that is
Okay.
a quite a big formula, right?
Yeah. So actually, that idea, right? The ratio of standard normal variate and the square root of chi-square variate divided by degree of freedom, right?
Yes,
So
yes, yes, yes,
that
yes.
follows the T distribution. Okay. So thing is that where you can use the T distribution. Okay. So if you can recall from stage 2 course, I will just give you idea. So we are using the T distribution to test the mean, Are you able to recall? See, there are two kind of test: Z test and T test, right? So we are
Yes.
using T test to test for mean, okay,
Mm-hmm.
and when variance is unknown to us, okay, and Z
Okay.
test when variance is known to us, okay. That's the
Okay.
different thing. So I'm just letting you know the applications of T distribution, okay.
Yes. Yes.
So now,
Yes.
if you have linear model, right,
Hmm.
then you will be having parameters beta naught, beta 1 times x,
Hmm.
beta naught plus beta 1 times x plus epsilon, right?
Hmm.
Beta naught stands for intercept and beta 1 will stand for slope, okay. So
Hmm.
thing is that if you want to, suppose you are interested to know the significance of beta 1, those parameters, right,
Hmm.
to test that this t distribution will be helpful, like you will do t equal to
Hmm.
beta 1. Those will come it later in after week 3 onwards, so I'm just telling you the some sort of idea. So
Okay.
how we are using t distribution: x bar minus mu divided by standard error of that x bar, right?
Hmm.
Correct. So
Yes.
what okay, can you guess what it will be in term in the case of beta 1?
Okay. Could you repeat the? Could you
uh,
please repeat the formula? I will just write it once again.
Okay, okay. So what is the formula for t test, t distribution?
Actually,
Okay, for okay. So formula is okay. Let me share my screen. Just give me a second. One second. Screen. Can you see my screen?
yes. Yes. Yes.
Okay. So this is the formula for t distribution, right? Okay. I
Okay.
mean x bar minus mu divided by s by root n. This is follows t and minus 1. Okay. Basically,
Okay.
what is this mu stand for? So x bar minus this is expectation of x bar. Okay. And this is s
Yes.
by root n is nothing but standard error of
And
okay. This is
okay.
something it will follow t distribution, right?
Okay.
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 Now, if you want to use that beta 1, okay,
Hmm. Hmm.
then what will be okay? First of all, what kind of hypothesis you can make?
That the beta one which we are using is correct.
Yeah, I mean, first of all, you will assume whether I mean this is insignificant. I mean, there is no significant. I mean, it's okay. Basically, what you can make the statement like you want to test whether this slope or you can
Hmm.
say beta 1 is significantly from 0 or not. So similarly, you will make alternative hypothesis as beta 1 is not equal to 0. Okay. Now,
Yes.
what we are doing hypothesis testing, we are framing the statement for our hypothesis, right?
Hmm.
Then this will follow the t distribution, right? Then
Okay.
what we'll do, so we will define t as, let's say estimate is beta 1 hat, okay. We
Okay.
got some then expectation of beta 1 hat, just try to relate with this formula and
Hmm.
divide by standard error of beta 1 hat, all right.
Okay. Okay.
So what will be the expectation of beta 1 hat?
Expectation of beta one x bar.
No, no,
No.
why x bar? No, no.
Beta
See,
one hat will
first of
be
all, let me tell you, this will be like this. Okay, it's unbiased estimate. Okay.
okay.
So
Okay.
it will be beta 1 hat minus beta 1 divided by standard error of beta 1 hat. Okay.
Hmm.
Basically,
Hmm.
so if you will do under your null hypothesis, right? So
Hmm.
under your null hypothesis, this should be okay. Tell me what should I write under the null hypothesis? What should I?
This should be equal to 0.
Which one?
The beta one will be equal to 0.
So I should write beta 1 hat divided by standard error of beta 1 hat, right? So this
Yes.
will follow Tn minus 1. Okay. So
T.
based on the values of beta 1 hat and standard error of beta 1 hat, okay, and this degree of freedom and all, you will decide whether it is significantly, I mean, what is the effect of your beta 1 hat? Okay, what is the effect of this slope, whether it is significantly different from zero or not. Okay, so this is the role of t distribution. Okay, are you able to relate this formula to this one, right?
Yes, yes,
Okay,
yes,
so
yes.
that is something. So these all things we'll see in the upcoming weeks actually.
Upcoming.
Okay,
Okay, okay, okay,
so I'm
okay.
hoping you got some sort of idea.
Yeah, yeah, yes, yes, yes. And
Hmm.
could you say the explain a little bit that chi-square where that is used for? Yeah, for
All right, so there are lots of applications of chi-square distribution, right? So I think, see, chi-square basically, okay, suppose I'm saying x, I have a random variable, right? So
hmm.
I will say, suppose I'm saying it is standard normal variate, okay?
Okay,
So if I will say x square, so x square normally follows chi-square with 1 degree of freedom, okay? So there are lots of applications of chi-square. For example, okay, so I told you to use to test for mean, right? What we are using, t distribution, correct?
okay,
So if you can recall, so if I want to test for variability, right, or test for variance,
okay,
okay,
yes,
so I will use chi-square test, because if you see the formula of chi-square test, what is this? In this case, what are the things? I have population variance, sample variance, okay? So
okay,
to test the variability of a data set, okay, we will use the chi-square distribution. Or there are another approach that those are not in linear statistical model, but I will let you know. So if you want to check, independence of attributes, okay,
okay,
so like if you are to to, let's say, categorical variable, you want to check whether those are independent or not, so you will make contingency table and all. So for that, formula is different, but I'm just letting you know the applications of chi-square distribution. For
okay,
this particular formula, if you I want to use, if you want to test the variability of a data set, I will go for the chi-square test. All right.
okay, 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 okay.
Yeah. Okay. Anything else?
No, not
uh, Ananya, Manaswita, anything?
I have a rather silly but general question in why are we like studying about linear statistical model? I mean, what makes them so special that we give them so much emphasis?
Okay, so first of all, see, this linear statistical model is something like that. Whatever we are doing, okay. For example, linear regression and all right. So how? Okay, what is the importance in terms of this statistics money? Okay, what I'm trying to say. So okay, have you heard about ANOVA, analysis of variance?
Yes, like more than two variables.
More
We use
than
that
two.
to test for more
Correct.
than
Okay.
two.
Okay. Do you know about sorry, fixed effect model and random effect model?
No.
No, no. All right. Okay. So actually, okay. So in linear statistical model, what is the basic idea? So the same thing, right? So suppose here we will start from linear regression. Okay. In linear regression, then we'll move to the multiple regression. I mean, simple linear regression to multiple. Then we'll move to the random effect model. Okay, so if you go if you see the ANOVA, right, analysis of variance, and ANOCOVA and all. So ANOCOVA stands for analysis of covariance. Okay, 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 let me come before. Okay, so what is the fixed effect model? Do you know? I mean, can you guess?
Maybe we are putting something constant, something fixed, and we're checking if there's an effect. I don't know, I'm just guessing randomly at
Yeah,
this
yeah,
point.
go ahead, go ahead, go ahead. Yeah, I mean, it's somewhat it's correct. That's not wrong. What about random effect model?
We change any of the variables randomly and check if there's an overall difference.
Okay. Okay, so basically, see, suppose I have model. Let's say I'm saying yi equal to mu plus mu I plus epsilon ij. Okay, so there are lots of uses. Okay, for example, uh, okay, let me write one. Let me share my screen. Maybe that will help you. Can you see my screen? I will write somewhat
Yes,
there.
yes.
Okay. suppose I'm telling you, suppose I have one, dependent very, let me write that equation. Let's say beta naught plus beta 1, let's say I'm writing, I can write x I t, okay, plus alpha I plus epsilon I t, and let's say y I t. Okay, you can assume this y as a, let's say I'm taking as a income, okay, and this x, let's assume this is the education, okay. So actually this is the, extension of the model, okay. So what is the meaning of that? So okay, how will you interpret this yit? Let's say I will let you know, accordingly you can proceed. So it's nothing but I will say income of the, ith individual, and let's say I'm assuming in year t, okay. Then this okay, how will you interpret this education thing? So it's a kind of,
Education of the
yeah,
individual.
in year
Okay,
t, right?
right.
Okay. So this alpha stand for, individual specific fixed effect, okay. This stand for fixed effect, okay. And this is the error term we know, okay, from, okay. So this will happen in case of fixed effect model, okay. So what is the thing in fixed effect model, I will let you know. So fixed effect model, what we are doing, so whatever individual here, right, individuals, let's say any candidate or person, so that individual specific effects, okay, so this assumes, we are assuming as a fixed, not a random, okay. So why, okay, what is the meaning of fixed? Suppose I have some, for example, I have k treatment, okay, okay. For example, I have k treatment, then I'm going to use all k treatments, okay. Or else I know these are the these are the particularly k treatments I'm going to use, I mean there is no change and all, okay. So this is something fixed, right? I'm going to take all the things, okay. What about random effect model? Okay, did you get some sort of idea, or still some confusion is there?
Um, I didn't understand the treatments part.
Okay, okay,
Where,
forgot about treatment parts. What about this?
yeah, we are assuming our alpha I to be some fixed effect
Hmm.
in determining the income of that person.
Correct. And if I will write the random effect model, right? So in the same scenario, this alpha I will be random. Okay.
Okay.
Okay. Okay. Let me take another example for the this treatment case. Okay. Suppose I'm saying you have K treatment. K treatment means, suppose you can assume K rations and all. Okay. So yeah, basically you can assume. Suppose you have some. You are interested to know the yield of milk on some different types of cow you have. For example, uh, okay, okay, okay. Let me write the things so that it will give you the idea. Very. Just a second. So I was mentioning this k treatments, okay. Suppose what I'm doing, suppose I am interested to know, suppose I'm interested to this effect of, let's say, k treatment, okay, k different treatment I have, okay. So what is this treatment? Let's say I'm interested to know, okay, treatment you can assume. Suppose I told the example of, let's say you have k different rations, okay. All right. So for which I am interested to know on the yield, okay, in the milk, in milk of, let's say, some n cows I have, okay, n cows you have, okay. I mean, are you getting this meaning of k treatments, something like that? Okay. So
Um, I'm,
what? Yeah.
I think the care treatments are like different food that we
different, yeah, rations with different food, different type of different types of food you are going to do. Okay, now what
okay.
I'm suggesting, suppose this, okay, what will be the role of this alpha I? This alpha I will stand for the effect of your ith ration. Okay,
Okay.
are you, or let's say ith food. Okay,
Right, right.
are you getting so far so good?
Yes,
Okay,
yes.
now I will let you know the difference between this fixed effect model and random effect model. Suppose what I'm trying to say, in fixed effect model, what it will be? Suppose you have K level, right? K level of the treatment, correct? Okay, and only these treatments are the only level of interest. Okay, I was I was saying in the beginning, whatever the things you have, those are the fixed, right? You are taking all the things, means suppose whatever the this rations are, you have, right? Or types of different types of food you have, these are the only levels of the interest, right? I mean, these are the treatments in which you are interested, right? I mean, you have taken only these kind of things. Okay, so
Can we say that
hmm.
these are when we are saying levels of interest about how much quantity of the food that we're feeding the cow? Is that a correct intuition? Like
No,
the levels of
not like
interest.
that. No, not like that. So level of interest means, suppose you have, let's say, for example, there might be, let's say, 100 types of different, no, 100 types of food. Okay, for
Right.
example. Okay,
Yeah.
suppose by your intention, or suppose you are an investigator, right? From your experience and all, okay, for your own interest, you took only 10 food. Okay, or 10 treatments. Okay, now what is happening here? You know, you are going to take only these levels of foods. Okay, these 10 classes or these 10 treatments you are going to take. Okay, all right.
Okay.
So now in
Yeah.
this case, I will say this alpha is are fixed.
Yes.
Okay, so what is the meaning of fixed after fixing? So in the fixed effect model, what you will do, the conclusion, whatever conclusion you will make, right, for your hypothesis, right, it will apply only these k treatments. Okay, are you getting my point? So these k treatments you took. Okay, and you know, these are the only levels of interest. For example, okay, suppose you took, okay, suppose you took fixed type of cow, and you know, the this kind of cow, or this on this breed, let's say, you know, only these kind of treatments will be applicable. All right, now you know only these 10 treatments will be applicable. Now this will be the fix,
Yeah.
or like, are you getting now? What is happening in case of random effect model? Okay, so in random effect model, what is the things, first of all, you know, suppose you have lots of treatments. Okay, lots of factor levels. Okay, then what you will do, suppose due to cost factor, due to, you know, other factors, let's say time, due to consideration of time, administrative and all, I mean, due to lots of parameters, what you are going to do, you are just taking a sample. Okay, just try to understand. Suppose you took a sample of k treatments. All right, let's say k1 treatments, for example. Okay, now suppose you took a sample of k1 treatments, and you did your analysis and all, hypothesis testing and all, and then what you are going to do, if you are going to make conclusion, right? And this conclusion, you know, it will be applicable for all the treatments. Okay, are you getting? Then in this case, I will say it's a random effect model. What I'm going to assume, this alpha I, in this case, it will follow some distribution. Is it some okay, some sort of idea you're getting or not?
Right. I mean, we are making, instead of taking all the treatments levels to be equal, we will take a
Correct.
sample of K1 treatments and then check its distribution, being alpha I.
Yeah, yeah, you will perform our hypothesis testing and all, and then will, if we are going to make you know, conclusion and all, so that conclusion will be valid for all the factors. Okay, all the treatments. Suppose you had this bunch of treatments, right? And out of this you took a sample of K1 treatments. Then after analysis, the conclusion will be applicable for all the treatments. While in the case of fixed effect model, what was the case? This conclusion will be applicable only on those K treatments. Is it clear? Some sort of
Yeah,
idea you are getting? Okay.
yeah,
So
yeah, it makes
so
sense.
main concern, what I'm trying to say, you will study simple linear, then multiple linear regression model, then you will see this random effect, fixed effect model. Okay, then you will move to the analysis of variance and analysis of covariance, and all. We'll have nested model. I mean, okay, first of all, normally we are seeing two-way classification, sorry, one-way classification. Then we'll see the some idea of two-way classification, then three-way classification. We'll not go in depth for three-way classification and all, but yeah, it's a just extension of your this linear regression onwards, and the same thing how we can perform in this R.
Okay, that is interesting. I mean, all this while I just thought that linear regression is like a simple thing. We were being taught linear regression in practically every course that we take, right? Like
Yeah.
but
Maybe you have seen linear regression or thing in ML and all, right? ML courses maybe you have seen, right? And anyway, in
but
ML courses we are, yeah. So
but
this
it
is,
has like
yeah.
a wide range of applications. I mean, we are
All
doing
right.
testing and all,
Correct,
so
correct,
it's
correct, correct.
interesting.
So for this, so you will see, normally we, okay, in, I think in MLF or MLT, where linear regression has been introduced,
Yes, yes, sir.
MLF or MLT, right?
Yes.
So, okay, there have they informed about this, how to estimate this beta 1 and all beta naught, or let's say variance of beta 1 hat means I'm talking about estimate of slope.
Not in that way, but actually, they did not go into the statistics part.
But basically they are told, right, this is the, let's say, if beta naught, I mean intercept plus slope into x plus epsilon, then okay, I
Yes,
got
yes,
it.
yes,
Okay,
yes.
okay, understood. So here what you will see how, okay, we know beta 1, what is the role of beta 1, right? So we are going to see the significant effect of and all. So here we'll see the statistical concept, right? So how we are saying that beta 1 is significantly different from 0? What are the, actually you will see here what is the backend statistics behind these kind of things. All right. So I think in the beginning of the session I told, if you see, let me reshare my screen. Uh, you see, in the beginning of the session I told, yeah, here. So we have seen the t distribution and all, right? So if you see this hypothesis, right, beta, whether beta, okay, so I will frame my hypothesis whether my beta 1 is significantly different from 0 or not, right? So then we'll see what is the t statistics. Then it will follow, I mean it will follow tn minus 1. It will depend on the number of observations. But yeah, so after this we'll see, we'll check whether the calculated t is greater than the tabulated one or not. So tabulated means this t, we are the values which we are taking from table and all. Okay, so if we will take the decision about whether beta 1 is equal to 0 or beta 1 is not equal to 0 or not. I mean beta 1 is equal to 0 or not, something like that. Okay, then okay, for example, suppose beta 1 is equal to 0 means, that means what? Your response is equal to, yeah, tell me.
True.
I mean, if I'm saying beta, suppose your hypothesis, null hypothesis is being accepted, then that means beta 1 is equal to 0, correct? Then your response will be equal to your slope, sorry, intercept,
Intercept will be, if beta 1 is 0, then intercept will be in the y-axis only.
correct? Okay. I mean, so what I'm trying to say here, so all the backend statistics we'll see here. It will require in the coming week. There will be some null space, column space, and all those. It will. I mean, you must know some sort of linear algebra as well. Okay. So later in upcoming week, you will see. See, normally we are saying unbiased estimator, right? So in case of linear model, there is concept called blue. Blue stand for best linear unbiased estimates. Okay, so there, okay, for a okay, suppose you have model, right? You have lots of data. Suppose you generated 250 or something like that. Then it's possible, there, okay, suppose there is beta 1 head. Okay, this is unbiased to beta 1. Okay, suppose there is another estimate of that slope which is also unbiased, but which one is the best? So we'll see, let's say I'm saying variance of a beta 1 is less or equal to variance of another unbiased estimate. Then I will say, yeah, this one is the best. Okay, so these are all kind of backend statistics we'll see. That is the basic agenda. I'm hoping you are I was able to answer your question.
Yeah, I mean,
So
it was a great overview. I mean, we pretty much had an entire overview of the course.
yeah. So basically the difference is you have to do on R. That's not, yeah. Okay, yeah.
So just a small question is
Hmm.
that so let's say if our objective is to get the beta one that you are talking about, so basically the slope.
Hmm.
Okay, so we have other algorithms like gradient descent and all to guess the perfect slope with
Hmm.
feedback, uh,
Hmm.
like mean RMSE and all that.
Yeah. Root mean is, yes.
Yes.
Hmm.
So instead of doing that, we will be doing this statistical approach.
Correct. This gradient descent ascent you are talking about, right?
Mm-hmm.
So you can see, have you done this statistical computing course?
Actually, not
No, okay. I
statistical
think
computing.
Manusita and Harsini has done. Okay, I think there is, right, in statistical computing this gradient descent ascent is there, right? So you can, okay, so those are things there. So actually statistical computing also based on, computing, basically computational techniques, and that is something we are doing on R also. Okay, so that's not a problem. So this linear statistical model will give you some sort of idea about R. Then
Mm.
if you are going to do statistical computing, then it will be helpful for you.
Okay.
Yeah.
So instead of that gradient descent, we will be doing this K
This
treatment.
correct. This basic, the I gave you, right, this
Uh,
random effect model, fixed effect model and all, right?
okay.
So
So, like, is there any reason for that? Like, is why we not go with gradient descent and go with this K treatment and all?
actually, see, you can see, you can assume this linear statistical model as a first level, and then statistical computing as a second level.
Hmm. Okay.
Okay, so first level we should start from basic foundation of those kind of things.
Okay.
So that is the case here.
Okay.
Right. Okay. So anything else? Anybody?
Um, would you like to provide any other resources apart from our material, which will help us learn art more uh, better? Like, I couldn't
Uh,
find good ones. Like, I do not know actually which ones are the best ones to like go over and do some extra practice for art.
Okay, all right. So what I was suggesting to Abhishek in the beginning, just okay. I will search something which you should give no idea from scratch. But what I will suggest as of now, you can just go under supplementary content. We have provided the code for, week 1 and week 2. Just go and try to, run line by line. Okay, and try to understand what is the going on, for, what is the function of every code. If still you are getting any difficulty, you can ask in the group. We are there. Also, I will search something which if I feel that is helpful for you, I will share in the group itself. Okay, in G space, everyone is there, I'm hoping. Okay? So I'll share in that G space for sure.
Okay, thank you,
Okay.
thank you.
Yeah.
You can go to the free code camp. There is one uh, YouTube channel called Free Code Camp. The video there I saw it is quite good for the basics.
Okay, so also you can see search. Yeah, I can remember one, but it's not related to this linear statistical. But if you want to get some idea, some basic idea about R, so you can see the Professor Siva course, right, in NPTEL. I think probability and statistics using R, something name is there. I'm not able to recall exact name. So he has started the basic statistics in R, how to do that. So you can watch that also. Meanwhile, I will check. I will check if there is something I will get. I will upload in the or I will share in the group first.
Sure, sure.
Okay. Yes. All right. Anything else? Anyone? Okay, so are you finding this week 1 and week 2 is easy, right? Or is anything difficult? I think this is something, it's just a recall, correct? Whatever you have done till now.
Yeah, I mean, it's been a refresher,
Uh,
but doing it with R is interesting. I mean, I'm not quite used to it, so I'm just like trying out different
yeah,
stuff.
no worries. Yeah, you can. You're getting any difficulty, just let us know in the group itself, right? Or discourse is there.
Yeah, sure.
Yeah.
Thank you.
That's, actually, R is famous for statistics purpose, majorly. Okay then. Is there anything else so we can discuss? Yes, no. Okay, nothing. If you want to discuss anything,
I think we will have more to discuss once we go to week 3.
okay, all right, that's not problem. Okay, so yeah, one more thing I wanted to ask to all of you. Okay, so if you need any session before due date, right? So I think due date for week 2 is Sunday, right? Week 1 and week 2 for both week. Okay. So if you feel, so you can simply inform in the group. Accordingly, I can plan. Okay. But yeah, do let me know. But do let me know at least one day before, right? If you need session, suppose tomorrow, then let me know one day.
Sure, sure,
Okay.
sir. But just
Mhm.
one thing that what is your name like in group if I have to tag?
Okay. So my name is Prasant sir.
Okay, sure. Thank you.
Okay, all right then. If there is nothing, then close.
Yeah.
Fine. Anything else? Minnesota, Ananya, Harsini?
Nothing.
No, sir.
No? Oh, okay. Okay, okay, then fine. Thank you. Thank you all. Let me know if you
Thank you, sir.
need any kind of.
Thank you.
Thank you, sir.
Okay, thank you.